Let's talk about centrifugal forces. Now, you might already have some idea of what they are. For example, you might imagine yourself on a merry-go-round being flung outwards by a centrifugal force. Or you might imagine spinning around and around as your arms get flung outwards by, well, the centrifugal force. No matter what you imagine, there always seems to be one thing in common, that it appears when spinning, and that gives us a hint to what it really is. But let's first address the elephant in the room. If you've ever taken a physics class in high school, you might have been told that there is no such thing as a centrifugal force. So let's begin there, why you've been told that the centrifugal force does not exist. Imagine you have a mass tied to a pole and you set it into motion. We know that acceleration is a change in velocity over the change in time. If we take any arbitrary interval in time, we can clearly see that the change in velocity is inwards. In other words, there is a centripetal acceleration. According to Newton's second law, there must be a force providing that acceleration. In this case, it's the tension from the string. And this is true for whatever case you consider. A car driving in a circle, friction provides a centripetal force. Spinning on a merry-go-round, there's friction and also the force the bars exert on your hands. Just spinning in place with your hands out? Well, your ligaments and stuff keep your arms in. So now the important question to ask is, why does it feel like there's a centrifugal force? Well, in order to answer that, we need to know how we feel a force. We don't actually feel external forces. We feel internal forces in our body. If the same exact force were applied to every single atom of our bodies, then we would feel nothing. For example, you don't feel gravity when free falling. Now you may ask, well, how come I feel gravity right now? The answer is you don't. What you feel is the normal force of the ground pushing on your feet. Since you see that you're not moving, your brain assumes that there must be some other invisible force that's acting equally on every part of your body, pushing you back down to balance with the normal force. And in this case, your brain is correct because, well, gravity does just that. Further, imagine if there were no force of gravity, but the normal force was still there, such as if we were standing in an accelerating spaceship. Then we would feel the same exact thing, even though gravity doesn't exist. The difference in this case is that we see that we're moving, and our brain doesn't have to invent a new force to explain our observations. When inside a spinning chamber, we feel a normal force pushing us inwards. Since it doesn't look like we're accelerating from the reference frame of the chamber, our brains assume there must be some kind of invisible centrifugal force canceling out with the normal force from the wall. And that's the key. The centrifugal force only appears when you're in a rotating reference frame. A rotating reference frame is not an inertial frame, meaning that Newton's laws of motions don't hold in it. For example, in a rotating reference frame, this mass will appear to be stationary, but we know that there is a net centripetal force. That breaks Newton's second law, since there is a non-zero force, but the acceleration in the frame of reference is zero. So what if we still want to be able to do physics in a rotating reference frame? For that, we have to introduce the invisible centrifugal force into the math. Here, the centrifugal force is said to be a fictitious force. A fictitious force is an invisible force that seems to emerge when you're viewing things in a non-inertial reference frame. There are more kinds of fictitious forces. For example, the translational fictitious force. Consider the scenario before where you're standing in a rocket ship accelerating in space. If you close your eyes in this accelerating reference frame, you would think that there's some kind of gravity pushing you down. And in fact, in Einstein's theory of general relativity, gravity is indeed a fictitious force. So what did we learn? Well, the answer to the question, does the centrifugal force exist, is that it depends. Just like so many things in the real world, one answer isn't necessarily right and the other wrong. It all depends on the perspective that you choose to look at things from.